random guy here. I'm going to talk about algorithm analysis, um, time complexity. I'm going to um, calculate the exact cost of any given algorithm. So let's first start with a simple example. I hope um, this should be an easy one for you. Let's write the loop. The loop is for loop, just a for loop, like for this is my integer I is equals to 1, I is less than or equals to n. This is one of the most simple loops or simple algorithm to compute, and it's going to be I plus plus. And here I'm going to write a simple statement which is print hello. Okay, in order to calculate the exact cost, first we need to understand some basic three asymptotic notation, like this omega stands for best time complexity, this theta stands for average time complexity, and big O notation stands for worst time complexity. So in order to solve the complexity or solve the algorithm exact cost, I am going to write a chart in here. And okay, so let's start with a box. In here I am going to write my number of steps. Oh, before that, first we need to understand n stands for user input. It is what? This is user input. Since we do not know what is user input, for my calculation purpose, I am assuming n is equals to 4. You can write in the exam as well, like let n is equal to 4, right? And I am going to write a few paras like steps. So I need to use this pen and need to reduce the strokes. Okay, so in here my first step, I'm going to write steps, steps. Second one is I, because this is my variable I. Third one is my condition I is less than or equals to n, and the last one is statement. Okay, so in my first step, what is the initial value of I? The initial value of I is 1, and we are assuming n is equals to 4. So is 1 is less than 4. Is it true? Yes, it is true. That means my statement is going to be executed and hello is going to be printed. Again, in the next step, what is my I? My I will be incremented as 2, from 1 to 2. So again we are going to check is I is less than or equals to, or 2 is less than or equals to 4. Is it true? Yes, it's true. That means I'm going to write the statement. It's going to be hello. Again in my third step is 3 is less than or equals to 4. Is it true? Yes, it's true as well, and my statement is going to be printed. When my step number is 4, my I is going to be printed, I is going to be incremented as 4. So is 4 is less than or equals to 4. Is it true? Yes, it's true. Less than is equals to 4 is not true. However, 4 is equals to 4. That one is true. This is 4. My statement is going to be printed. And the last step, I. When my I is incremented from 4 to 5, my condition is going to be checked. So is 5 is equal or 5 is less than 4, is it true? No, it's not true, it's false. That means my statement is not going to be printed. If we analyze this algorithm, my question was exact. My question was exact. Exact analysis. My question was exact analysis. So we are going to be calculating the exact complexity. So let me check this, and I'm going to do for the first one only. My condition, for n inputs, like for n inputs, for n inputs, how many times my condition has been checked? 1, 2, 3, 4 and 5. My condition checked for 5 times. My condition checked 5 times. 5 means what was my value of n? User input was 4, but my condition block ran 5 times, which means n plus 1 time. For n input, n plus 1 time. What is n plus 1 time? This is my condition, right? What about my statement? What about my statement? What about my statement? My statement ran 1, 2, 3, 4. My statement ran exactly 4 times, which means my statement ran n times. So by analyzing this algorithm, let's compute my for loop. So this is my for loop. For I 1, I is less than equals to n, I plus plus, and this is my print statement. Print was hello, right? Let's compute for n input, this line executed. For n input, this line executed n plus 1 time, right? And for n inputs, this line executed only n times, exactly n times, right? So what about my total cost? My total cost is my total cost for this algorithm is n plus 1. You can multiply by c as well. This is not mandatory. I'm not going to do this, but you can multiply by cn plus c or c into n plus 1 cn. This is not mandatory. N plus 1 for the first line, and my second line ran for n times, which means 2n plus 1 times. And if I represent it using asymptotic notation, it should be order of n times, because all of my constant term are going to be eliminated since they are not very significant. So this is my answer. I hope you like this.